Welcome to mathematics classes. Today we will see some critical integration questions. This is the part 2 of the video. Okay. Few problems we have solved before which are critical, and this is the other set of problems. Okay. So these are mainly for JEE and BITSAT preparation or any other engineering entrance exam. Let's get into the integration questions. Yeah. You can read the question. Okay, so this is the integration of basically integration of square root of x square plus 1 plus x whole to the power of 10 divided by x square root of x square plus 1 minus x whole to the power of 9 dx. We should write in this format. Okay, then what is the value of m plus n? Okay, so first thing is look at this integration. Okay, these two are surds actually, and these two surds, if you multiply them, you get 1. That is what you should remember first. Okay, surds you should understand very well. Okay, so if you multiply these two, numerator and denominator without powers, this is 1. Okay, which means, okay, very simple, right? Which means if I take square root of x square plus 1 plus x as t, then square root of x square plus 1 minus x is 1 by t. Okay, now let's see what is the differentiation of this one, right? Dt, dx also I have to replace if I convert into a t, right? So that is x by square root of x square plus 1 plus 1 dx equal to dt. Now if I take this LCM here, okay, this is nothing but square root of x square plus 1 plus x divided by square root of x square plus 1. So now this is again t, correct? So I wrote it as t divided by square root of x square plus 1 dx equal to dt. Now this is what is this? If I sum up these two, t plus 1 by t, I get 2 times square root of x square plus 1. So half of t plus 1 by t is this value, correct? Half of t plus 1 by t. Now I have all the values, just replace in terms of t. Okay, this is nothing but integration is nothing but half of t to the power of 10 divided by 1 by 2 to the power of 9 into dx is nothing but t square plus 1 by t square. If I take LCM this one and reverse, right, this is in the denominator, t square plus 1 divided by t square dt. Okay, this is nothing but half of integration of t to the power of 19 plus t to the power of 17 dt, which is nothing but t to the power of 20 by 40 plus t to the power of 18 by 36 plus constant. Okay, now you take LCM, make it a common this one. I is nothing but 9 times t to the power of 20 plus 10 times t to the power of 18 divided by 360 plus constant. This I write in this format, 1 by 360 into t to the power of 18 if I take common into 90 square plus 10 plus c. Now we actually solve the integration. Only thing we have to do is we have to represent in this form. Okay, now replace t back. Okay, this is what I get, 1 by 360 into square root of x square plus 1 plus x whole to the power of 18, which is there in this format. Fine. Okay, so my m and n almost I got actually. Only thing is this is not exactly in this form. Okay, either you can ignore, mostly you already got it actually, but we don't know, right? We may get one more this term so that power may become 19 or power may become 17, we don't know. Okay, so just make sure that this is in this form. Okay, so now how do you do that? Okay, this is nothing but 19 x square plus 9 plus 18 into square root of x square plus 1 plus 10. Okay, so this is same thing I wrote it, the 19x square plus 18 times this one plus 10 plus 9, 19. Okay, now if I take x square plus 1 as common, square root of x square plus 1 as common, then from this 19x square plus 19, I can write this as 19 into square root of x square plus 1 plus 18x as is. Okay, I'm trying to just put it in this form. Okay, understand that. Okay, now carefully do this. 1 by 360 into square root of x square plus 1 plus x whole to the power of 18 as is it is there. Okay, next step, carefully. This is, I can rewrite this one as 19x plus 19x minus x. Okay, and I'm taking 19 as common. So this will become, if I take, okay, 19 times square root of x square plus 1 plus x. Okay, because this is 19x, and then I have a minus x, correct? I have a minus x. Okay, now that I will, if I multiply this with this, actually what I will get is another one, another same thing I'll get is square root of x square plus 1 minus 1. This is what I'll get, minus x, sorry. Okay, because this is 19x minus x, right? So now actually I got one more term of square root of x square plus 1 plus x. Okay, so this power becomes 19. Okay, so 1 by 360 into square root of x square plus 1 plus x whole to the power of 19 into 19 times square root of x square plus 1 minus x plus constant. Now it is very clear that my m is 360 and n is 19, correct? m plus n is 379. That's the answer. Okay. Next. If 2x square plus 5x plus 9 integration of 2x square plus 5x plus 9 divided by square root of x square plus x plus 1 dx equal to x times square root of x square plus x plus 1 plus alpha times square root of x square plus x plus 1 plus beta times log of x plus half plus square root of x square plus x plus 1 plus constant, then what is alpha plus 2 beta? Basically solve this integration, put it in this form. That's it. You will get your alpha and beta, correct? So whenever you see such integrations where polynomials are there and in the denominator you have square root terms, right? What you have to do is you express the numerator in terms of take polynomial only. Don't take the square root, okay? In terms of this polynomial plus constant times polynomial or a times polynomial plus b times differentiation of polynomial plus constant c. Okay, I'll show it here how to do. 2x square plus 5x plus 9, which is numerator. I am expressing this as a times x square plus x plus 1, which is denominator square. Okay, if I remove squares from the square roots from the denominator, this is what I get. A times x square plus x plus 1 plus b times differentiation of this one, which is 2x plus 1 plus constant. Now, if I solve, this is very simple, right? A equal to 2, b equal to 3 by 2, and c is 11 by 2. This is what I will get. Okay. Now, this is very simple. Integration is nothing but, okay, integration is nothing but 2 times, okay, 2 times. If I divide with the denominator, what I will get is integration of square root of x square plus x plus 1, because numerator is this value, right? A is 2, right? So 2 times integration of square root of x square plus x plus 1 dx plus b is 3 by 2. Okay, so 3 by 2 into integration of 2x plus 1 divided by square root of all this dx plus 11 by 2 into integration of dx by the square root of this value. Now this is very simple, right? These are all standard forms. And this is nothing but 1 by square root of t. Okay, if t is x square plus 1, this is 1 by square root of t. And this is, these two are standard forms, right? So let me put the answer here. So integration is nothing but 2 times. Okay, if I write this, represent in this form, x plus half whole square plus root 3 by 2 whole square dx. This is nothing but 3 by 2 integration of dt by square root of t plus 11 by 2 into dx by square root of x plus half whole square plus square root of 3 by 2 whole square. Okay, now integration is here 2 times, write it carefully, x by 2, here x is x plus 1 by 2, so x plus 1 by 2 by 2 into square root of x square plus x plus 1 plus 3 by 8, that is 3 by 4 into 1 by 2, 3 by 8 log this whole value, basically x plus half plus square root of x square plus x plus 1. This is first part. Second part is simple. This is 3 by 3 into square root of x square plus x plus 1 I'll get. Basically, I'll get, instead of this whole integration, I get basically 3 times square root of t. That is here. Plus 11 by 2 into, this is nothing but log of x plus half, okay, plus square root of x square plus x plus 1. Okay. Now this is simple. Put it in this form. Okay. I need x into, I don't need, alpha is basically coefficient of square root of x square plus x plus 1, which is nothing but, if I see here, I get 2 gets cancelled, half into this value, half into this value, plus here there is one more term. So alpha is nothing but half plus 3. Alpha is nothing but half plus 3, which is 7 by 2. And what is beta? Beta is coefficient of log. Okay, coefficient of log, there is one 3 by 8 here, there is one 11 by 2 here. Okay, so which is nothing but 25 by 4. Now, alpha plus 2 beta is nothing but 7 by 2 plus 25 by 2, which is 32 by 2, which is 16. That's the answer. Next. Integration of minus 1 to 3 by 2 of modulus of pi square x sine pi x dx. Okay. So this is a simple one. Pi square is anyway positive, you can take it out. So this is nothing but integration of x sine pi x dx. Okay, then apply the limits. Okay, only thing is be careful, this is a modulus. So first thing is convert the limits appropriately. Okay, so that you can solve the problem. Okay, so this is the given integration which I want to solve. So this is nothing but pi square of integration of minus 1 to 1 x sine pi x dx. Why did I split it like this? If I apply minus 1 minus x sine of minus pi, correct, which is anyway positive, so this will become positive anyway, so I don't require modulus. So minus 1 to 1 plus integration of 1 to 3 by 2 x sine pi x dx. So in both the cases I need to basically solve integration of x sine pi x dx, correct. So first we'll solve that one, Okay, and of course, just to simplify this, this is minus 1 to 1, so I can call this as 2 times 0 to 1 integration of x sine pi x dx. Okay, now let's find out integration of x sine pi x dx. I am applying the product rule basically. Okay, so my x is as is, and then integration of sine pi x is nothing but minus cos pi x by pi, so that is here, plus integration of differentiation of x is 1, then integration of sine pi x is minus cos pi x by pi, so minus into minus will become plus here, so integration of this value. Now this one is cos, so simple, so this is nothing but integration is minus x by pi cos pi x plus 1 by pi square sine pi x. Okay, now only thing is be careful when you are applying limits. Okay, this is the integration for both of this, only thing is limits are different. Okay, so this is the integration, you need to apply both the limits, multiply it by 2 for 0 to 1 limit, and then of course whole product you can multiply with pi square. Okay, so careful in applying. So pi square I kept it as is. The first one I am applying 2 times, and then this whole integration 0 to 1. Okay, if I apply 1, this will become 1 by pi minus 1 by pi cos of pi, which is minus 1. Okay, so this will become 1 by pi. So 2 times inside it is 1 by pi plus or minus. Okay, and here if I put substitute x equal to 1, this is sin pi is anyway 0. Okay, now if I apply 0 limit, this is 0, this is 0, so there is nothing, 0, minus same integration, apply limits from 3 by 2 to 1. Okay, 3 by 2 to 1. Okay, which I am doing applying here. When you apply, what you will get is basically when you apply 3 by 2, you get minus 1 by pi square and then minus 1 by pi, which is anyway with ddt here. Okay, so this is nothing but if you simplify, you get I equal to 3 pi plus 1. This is the answer. Okay, next. Let f of x be a positive function. I1 equal to integration of minus half to 1 2x times f of 2x times 1 minus 2x into dx. I2 is nothing but integration of minus 1 to 2 f of x into 1 minus x dx. Then what is the value of I2 by I1? Okay, so basically find out both I2, I1 and then solve it. Or you, when you are trying to solve I1, actually you actually get I2 as a byproduct. Okay, let's see how. I1 is nothing but this integration, so I will consider 2x as t. If I take 2x as t, 2 dx is dt, and limits will become, as x is tending to minus of, 2x will tend to minus 1, so t is minus 1. Okay, and as x is tending to 1, 2x will tend to 2, so t will be 2. Okay, so minus 1 to 2, correct? So integration I1 is nothing but half of, okay, because 2 dx is dt, right? So half of integration of minus 1 to 2 t into f of t into 1 minus t dt. Okay, now we can do one thing. We can actually always replace t, the variable, with the sum of limits minus variable, right? So t is equal to 2 minus 1 minus t. Substitute t equal to 2 minus 1 minus t, which is 1 minus t. If I substitute, same I1 will become half into integration of minus 1 to 2 1 minus t into 1 minus t into t, f of 1 minus 2 into t, which is same anyway, no change. Only thing is I got, instead of t, I got 1 minus t. That is the only new thing. So this integration, okay, this integration, if I take 2 to the other side, 2i1 equal to, 2i1 equal to integration of minus 1 to 2. I am splitting this into two integrations, which is first one is f of t into 1 minus t dx minus integration of minus 1 to 2 t times f of t times 1 minus t dt. Actually, sorry, these are all dt's. Okay, these are all dt's. Okay, now if you carefully observe, this is nothing but my 2i. Okay, if I take 2 other side, this is same, correct? So this is 2i. Okay, and this is my I2. This is my I2, which is exactly same. So 2i1 equal to I2 minus 2i1, which means 4i1 is I2 or I2 minus I1 is 4. Okay, so this is the ratio. Next. Yeah, read the question carefully. Let f of x plus 2 f of 1 by x equal to x square plus 5 and 2 g of x minus 3 g of 1 by 2 is equal to x, where x is greater than 0. If alpha is integration of 1 to 2 from 1 to 2 of f of x dx and beta is nothing but integration from 1 to 2 of g of x dx, then what is 9 alpha plus beta? Okay, first thing is find out what is f of x, what is g of x, and then find the integrations. That's it. Okay. So whenever you see such things, f of x, equation involving f of x and f of 1 by x, what we should do is we should replace x with 1 by x. Okay. This is my first equation. If I replace x with 1 by x, what I will get is f of 1 by x plus 2 f of x equal to 1 by x square plus 5. This is my second equation. If I solve these two equations, I get my f of x. And of course, if I want, I can get my f of 1 by x also. Okay, but here I am interested only in f of x, correct? So I'll solve for f of x. I get my f of x. F of x is nothing but 1 by 3 into 2 by x square minus x square plus 5. Okay, this is one equation which I got it. Just I need to find out integration, apply limits, that is alpha. Okay, next. 2g of x minus 3g half equal to x, which means g of x is nothing but x by 2 plus 3 by 2 into g of half. Okay, this is my g of x. Okay, and this is, remember, this is all constant actually, right? Only thing is I need to find out what is g of half. How can I find this? Simply substitute x equal to half. You get g of half here, g of half variable here, so you will get value of what is g of 1 by 2, correct? Substitute x equal to 1 by 2. So g of 1 by 2 equal to 1 by 2 into 1 by 2, which is 1 by 4 plus 3 by 2 into g of 1 by 2. If I take all g of 1 by 2 terms to one side, what I will get is g of 1 by 2 value, which is minus half. If I substitute here, my g of x is nothing but x by 2 minus 3 by 4. X by 2 minus 3 by 4. Remember this. Okay, this is my g of x. I am done actually. Okay, I got my alpha, I got my beta. Just apply integration. Okay, alpha is nothing but integration of 1 by 2 f of x dx, which is alpha, that is equal to integration of 1 by from 1 to 2, 1 by 3 of 2 by x square minus x square plus 5 dx. Sorry, this is dx. Okay, so that is 1 by 3 into minus 2 by x minus x cube by 3 plus 5x. Apply the limits of 1 to 2. Okay, so alpha is nothing but 11 by 9. Okay, apply carefully 1 to 2 limits. Okay, 2 first you apply, then minus 1. Okay, alpha is 11 by 9. Similarly, beta is nothing but integration of integration from 1 to 2 of g of x dx, which is nothing but x by 2 minus 3 by 4 dx. From here I get x by 2 minus 3 by 4. Okay, which is nothing but x square by 4 minus 3x by 4. Now you apply limits 1 to 2. Okay, so beta is 0. Okay, beta is 0. Now my 9 alpha plus beta is nothing but 9 alpha plus beta is nothing but 11. That's the answer. Okay, next. Yeah, the value of integration from minus 1 to 1 of 1 plus square root of modulus of x minus x into e to the power of x plus square root of modulus of x minus x into e to the power of minus x divided by e to the power of x plus e to the power of minus x dx. Okay, this looks very complicated. Okay, whenever you see modulus, you check the limits. Okay, in the limits where it will be negative, where it will be positive, first divide that. Okay, make it into two limits. How can we do that? This is the given integration. I can rewrite this as from minus 1 to 0 of the same integration plus 0 to 1 of the same integration. Now I know in this range minus 1 to 0 modulus of x is negative, which is minus x. In this range modulus of x is positive, that is x, correct? So if I replace that, my integration will become, first part, integration from minus 1 to 0 of 1 plus minus x, which is square root of minus 2x into e to the power of x plus square root of minus 2x into e to the power of minus x divided by e to the power of x plus e to the power of minus x dx. Okay, plus if x is positive, this will become 0, this will become 0, whole thing. So I am left with, okay, I am left with this is my first integration here. Okay, second part is integration from 0 to 1 of e to the power of x dx divided by e to the power of x plus e to the power of minus x. I'll be left with only this e to the power of x into 1 on the numerator. Rest all gets cancelled for 0 to 1. That is, the modulus of x is positive, correct? So now you consider this as I1, okay, and solve it separately. Okay, this is my I1 minus 1 to 0 of this value. Now what I will do is, my I1 is nothing but, if I carefully take this out, e to the power of x into 1 is e to the power of x divided by the denominator here plus minus square root of minus 2x, sorry, plus square root of minus 2x if I take common. Okay, I am left with e to the power of x plus e to the power of minus x divided by same thing. So which is, I am left with only square root of minus 2x dx. correct? This is my integration. Now substitute x equal to -1. So dx is minus dt, and the limits will change from -1 to 0 to 1 to 0. Okay, so integration will become I1 will become 1 to 0 of e to the power of minus t divided by e to the power of minus t plus e to the power of t plus square root of 2t into minus dt, because dx is minus dt, correct? Now since this minus, you can take it out, cancel with reversing the limits 0 to 1. So I1 is nothing but integration of 0 to 1 of e to the power of variable. You can write anything you want, right? Sorry, this is x then. Okay, e to the power of minus x divided by e to the power of minus x plus e to the power of x plus square root of 2x dx. Okay, now if you compare with this, okay, you already have something here, right? My I is nothing but this I1 is here plus this one, and the limits are same, both have same limit, 0 to 1 integration, 0 to 1 integration, so I can combine them. So my this part adds with this part and becomes 1, correct? So my integration is nothing but integration of 0 to 1 1 dx plus integration of 0 to 1 square root of 2x dx, which is nothing but x plus 2 root 2 by 3 into x to the power of 3 by 2. Now you apply the limits 0 to 1. 0 anyway, everything will become 0, so you don't need to worry. 1 if you apply, what you will get is I is equal to 1 plus 2 root 2 by 3. Okay, this is the answer. Next, let the domain of the function f of x equal to log of 3 plus 4x minus x square. Okay, and the bases are different, you check it here. The outermost log has base 2, middle one is base 4, innermost one is base 6. Okay, the domain B of this one be a comma b. Then if integration of 0 to b minus a of gif of x square dx, gif is greatest integer function, is equal to p minus square root of q minus square root of r, where p, q are all natural numbers and their GCD is 1. Okay, then what is the value of p plus q plus r? Okay, question looks very big, okay, but it is very simple. First thing is, whenever you see domain, okay, remember your first chapter in NCERT class 11th and 12th. Okay, very easy to find domain. Okay, that is a comma b, you will get it. Once you get a comma b, this is just simply an integration of gif function. How to do that, we'll see. Okay, so consider the innermost log for domain. Okay, whenever you see, do you want to find domain, right? So for this domain, log should be always greater than 1. So innermost log you take, which is log 3 plus 4x minus x square to the base 6 should be greater than 1, correct? Which means 3 plus 4x minus x square should be greater than 6. If I rearrange this, this is nothing but x square minus 4x plus 3 should be less than 0, or x minus 3 into x minus 1 is less than 0. Okay, that means my domain is x belongs to 1 comma 3, which is a comma b. So a is 1, b is 3. Now I got my a comma b. Now it's all about integration, right? So integration of 0 to 2, 0 to 3 minus 1 is 2 of gif of x square dx. Now this gif of x square, you break these limits basically into where it will be 1, where it will be 2, where it will be 3 or 4 or 5. Okay, whatever comes, you break it into. This is x square. Okay, so this I can rewrite this as integration of 1 to square root of 2. Okay, so this will become 1 to 2. In 1 to 2, gif of up to 2, right? Gif of x square or gif function from in 1 to 2 will be always 1, correct? So this is integration from 1 dx, and next is integration from square root of 2 to square root of 3. So this will become from 2 to 3, because x square, right? Here 2 to 3, this will be always 2, gif is always 2, plus integration from root 3 to 2, this is nothing but 4, of course, because this is x square, gif of x square, right? Here gif will be 3, correct? So simple. Now this is nothing but integration from 1 to square root of 2 1 dx plus integration from root 2 to root 3 2 dx plus integration from root 3 to 2 3 dx. Okay, so this is simple. First one is x, right? Everything is x, 2x, 3x. I'll just apply the limits, right? X, and I am applying limits root 2 to 1, which is so root 2 minus 1. 2x I am applying limits root 3 to root 2, which is root 3 minus root 2. 3x I am applying limits 2 to root 3. Okay, that's it. This is my I. Simplify it in these terms. Okay, p minus square root of q minus square root of r, which is nothing but 5 minus square root of 2 minus square root of 3. So my p is 5, correct? Q is 2, r is 3. So p plus q plus r is 10. That's the answer. Okay. Yeah. So these are all the problems which I have collected, which are very interesting, and you need to apply logic from other chapters also actually in these problems. Okay. So integration becomes more and more tough actually. So the only way to practice is practice from basics to complicated questions. Okay. So watch my shorts also. Okay. All the easy questions I am solving in the shorts actually. Okay, and only the critical questions, complex questions, and some where some formula or trick to be learned, actually I'm using the videos. Okay, hope you enjoy this maths. Okay, keep doing maths. I'll come up with more videos. Thank you.